Hi there, my name is Boromai, and our group is here today to do the presentation on our Brownian models. What we're going to go through today is myself, I'm going to talk about the theory of the geometric Brownian models, as well as the certain and uncertain components of the formulas. Andrew will talk about our model design and setup, as well as the coding of the simulation. Troy will talk about the coding of the charts, as well as demonstrations, and Vamil will talk about the problems and some issue that we face during our coding. So the geometric Brownian model is a continuous time stochastic process in which the logarithm of the randomly varying quantity follow the Brownian motion. So we found that there are a few assumptions to the model. So there are 5 of them. The first one is the continuous and times and value. Secondly is the current stock price and how it could help determine the future stock price. So what we're going to do later is that we're going to demonstrate input the current stock price and create a chart that will help us determine the stock price in the future. Thirdly is the price of the stock as a the log abnormal distribution. The fourth one is the continuously compounded return for the stocks is normally distributed. Lastly is the certain and uncertain components, which I'm going to talk more in depth about the formula. What we have here is the formula for the that represent the certain and uncertain components to the stock price. So what we have here, this bit is the certain component and this bit is the uncertain component. Of course, the mu is the representation of the expected rates of return, and the sigma is representing the changes of the stocks in the future. So now we are going to go into the explanation of our simulation and the coding.
Hello, my name is Andrew. I'm presenting my part in our group project for the Brownian Motion Model. Our model has been set up to display features like interactive input variables for simulation, click buttons to activate functions, and table arrays to display the simulation output variables. So I'll just display those as follows, and some of the code also included for our simulation. This is the layout of our simulation model. In the top left-hand corner we have our input variables for stock price, time increment, expected return, volatility and time. Down the left-hand side here we have our click buttons, a click button for simulation, click buttons for 3 charts, and 1 click button to clear charts. Our 3 table arrays we have here. Our first table array displaying certain and uncertain stock prices, a second table array to display averages, and our third table array to display the variance between certain and uncertain stock prices. Our VBA code used for simulation was designed to colour various ranges in the worksheet, set dimensions and values, clear previous input variables, provide input boxes for new input variables with conditions, with interaction with the user, generate random shock from normal distribution, and display output variables for certain and uncertain stock prices with averages and variance. Here's a snapshot of our simulation code used. We started by adding colours to various ranges in the worksheet. We defined our dimensions and their values. We cleared previous data so that we could have interaction with the user to input new variables, and then we have our code to simulate our prediction for stock prices. And last code on the right hand side here is to clear the chart before we start again.
Hi guys, my name's Troy and I am presenting my part on the Brownian Motion Model for Finance 415. As you can see behind me, I did the coding for the charts, and I'm just going to run through kind of how we went about getting our information and the steps we used, and then a bit more run through problems and issues that we had, and then finally we'll run through the code and simulation and show you guys how it works. So first off, we needed to find the codes online. We were not really given specific details on how to do this, so we kind of just went on Google, had a bit of search, bit of free rein to find out how we were going to do that, and find the information required to do the coding. And we came across a lot of code variation and different ways to the same chart, so we had to find out what would fit our data the best and how we wanted to present our simulation. This included graph types and using the right Excel information, including using Excel 2016 coding, as there's a lot of older models out there, 13 and behind, so this is very vital to getting our coding to work. And there was obviously a lot of tweaking and playing around with very small parts of our code to make it work exactly how we want it to. And lastly, there was a lot of modifying and adjusting the chart attributes, which including title name, the legend, series names, and so on. And yeah, so for problems and issues, I'll pass you on to Bim.
Hey, I'm Bimal. So me and Troy did coding for our charts for the Brownian Motion Model. So I'll be talking about our issues and problems that we faced while coding for the charts. So the first problem that we noticed was the codes were kind of an older version, so and they weren't working with the current Excel model. We also had a bit of problem with the debugging the codes and technical issues. So the technical issues were that they worked in one computer and didn't work on another computer. So like we did the codes in the Unilab computers, and while we went home to work on it on our personal computers, it didn't work. Personally, I think I was frustrated with the codes not working occasionally, as in it was my first time using the VBA model. We also had problems like just structuring the whole assignment, as in we didn't have a clear outline of where to start, where to finish, and what structure of the assignment we had to do. So the next part of this simulation will be talking about the charts. Sweet.
And this is our code here for our chart. This is going to be showing our average stock price code. So starters, we've got a title up there to create chart 1, which obviously the purpose is to create a chart. This is our data range here. So that's what we're going to enter in. Create a chart. So that's setting the chart as the active sheet and what chart type we want is in there. That's the code. And this is giving it the data. So it's saying that that's the range that we want to use, is the range up here to show the chart, to show the data on which chart. And this is the chart type. So this is the code for the line graph, which we've used in all three of ours. And yep, this is the example for our average stock price. And the add-ons here, the modifying of the little add-ons and stuff. So this is the chart title, making sure it has a chart title and what the chart title actually says, and the legend and the series name to make sure that the line actually exerts a name. And yeah, that is our code for our average stock price chart. Hey guys, Troy here again, and I'm going to show you the simulation of our coding. So, first off, obviously click on simulation, and it comes up with this. So, and we're going to enter stock price between 0 and 100. So we go for 54, and now it comes up with an increment, value between 0 and 20, 15, and then enter an expected return as a decimal. We'll go for 0.7. Volatility as a decimal for percentage, 0.3, and then enter a time, which must be between 0 and 100, 15. Cool, and that produces all our data here, as you can see. And now to run the charts, which we did the coding for, we click on this one here. So it's a certain and uncertain chart, the comparison, and that's the stock price there. Certain red, uncertain green. And then to clear the chart, we click clear chart on the bottom, boom, it's gone. And now the averages chart, this just shows our average stock price. Once again, clear it down the bottom. And the third one is our variance chart, which is certain is the blue, uncertain red, and the variance is the green worm there. And yeah, that's our simulation runs for our code.